Hello everyone, today we'll demonstrate how our Battleship program works. For this demonstration, we are using a single one-by-one ship to make it easier and faster. We will start with the first tier. First of all, we will need to start the server, and here it goes. Additionally, we will need the clients, which will run on separate terminals, so let's do that. And for tier 1, we only need 2 clients, so here it goes. Here's the first client. We can enter the username and the password. Since it's a new account, we'll have to register it, so let's register it. Let's put in the password. Now let's do the second client. As you can see, we do not have the concurrency issue, as now the prompt occurs first and then the user can input. So let's do an input to show it. Now we can see that after the input we get the result and then it starts the player's turn. So this shows the mechanics of the game, and additionally it also reports the outcome, that is if it's a miss or a hit. So this concludes tier 1. So in tier 2 we have implemented input validation. So I'll show you what kind of input validation we have. So let's put some invalid inputs such as AA. As you can see, it has been rejected and it's still returned. So, and now let's put the correct input, A1. Yep, as you guys can see, it has been accepted and it's a miss. And now it's the other player's turn. So now I'll show you guys the pre-move functionality that we have implemented. That is, if a player inputs out of turn, we consider that as a pre-move, and once it's his turn, that move will be played. So let's show you guys what we did. A2, and now the A2 has not been played, but it's still there in the memory. And now when the second player will play, this will happen. So now, as you can see, this player played, and then the pre-move one, the pre-moved was played. Now let's end the game by hitting the ship. We'll show you guys that the server doesn't crash once the game ends. Rather, it allows to start new games between same players. Okay, so as you guys can see, there's a prompt that asks both users if they still want to play or no. So we'll say yes, and you guys will see that the game starts again between those two players. As you guys can see, now both players have started a new game. Also implemented a timeout that is a 30 seconds inactivity and will result in a turn forfeit. So we'll wait for 30 seconds and you guys will see that the player's turn will be forfeited to the other players. As you guys can see, Sam's turn has been forfeited and now it's Dom's turn. Additionally, we have implemented additional clients, meaning that if more clients join, the server will not crash. Rather, those clients will be kept into a waiting lobby. So I'll show you guys what happened when a new client join. So let's make one join. As you guys can see, now the new player Tim, he's just a spectator and he's just waiting, and it doesn't affect the game. So this is the whole implementation for tier 2, and we'll now move to tier 3. We need to implement a multiple client handling. So right now we have 4 clients. 2 of them are going to be players and 2 of them are going to be spectators. We already have the 2 players set up. Now we're going to set up the 2 spectators. As you guys can see, the program doesn't crash and it still works. So now we're going to play a fire operation and see what happens. As you guys can see, the result of the file operation and the result of the timeout is shown on both spectator screen. So this was you, it's just a timeout, and it's also said what who the spectators are, whose turn it is, and what happened. And it's here on both spectators, as well as they receive the board of both players. Now we'll show reconnection support. That is, if a player disconnects and connects within 60 seconds, he will return back to the game where he left. So let's disconnect a player and get him back into the game. Okay, he's disconnected. Now let's get him back into the game. Okay. As you guys can see, it's the same position where they left, and the game can still continue. If they exceed that 60 second, they will forfeit the match and the other player will win. So let's show that. Now let's wait for 60 seconds and see what happens. As you guys can see, he forfeited his game and this one won by forfeit, and both of them, they are removed from players, and the two spectators are now promoted to players. Actually, to choose spectators, we use FIFO protocol, which means that the first one will be the first one to be promoted to a player. We've implemented that using a priority queue, which can be seen on the code. And that's it for tier 3. We'll now move to tier 4.
For tier 4, in tier 4 we have implemented tier 4.1, which is custom low-level protocol with checksum. First, let's take a look at our custom protocol. I will show you an image. As you can see the image, which says, firstly, let's look, there is a 4-byte magic identifier here, which identifies our protocol. Then there is a 2-byte message type, which will basically identify which type of message it is. Is it a fire message? Is it a result message? Or is it a place message? Are we placing a ship? Are we firing a ship? Or are we showing the result? Then there is a sequence counter, which is basically a 2-byte sequence number to prevent replay attacks. Then there is a vector field, which is used in tier 4.1 as an encryption layer, which I will talk further while talking about the encryption layer. Then there is a 4 bytes for checksum to detect corrupted packets. Then there is a 4 byte for payload length. And then finally the variable length. Now let's start the server. Here we start our server. Here we will start first client. Let's say our first client has successfully entered the game. Now the game started. As you can see, I will enter F2. This A2 will get encrypted and then sent to the second client, and then we will get a result miss. This result will also get encrypted. Now we will talk about the encryption layer. As shown in the previous photo about the custom low-level protocol, we are basically now using a cryptodom. We chose this because it functions as a stream cipher, handling the data of any size. So basically, if the data is so big, let's say, it will still handle no matter what. Our encryption implementation required extending our packet. Basically, our packet didn't have the vector field, but now we have the vector field, which basically handles the encryption of the data. The encryption process takes the plain text payload, encrypts, and then move forward. Basically, this is how our encryption now looks like. This self.vector field will basically encrypt the packet and then send it forward. For security features and mitigations, what we are doing is we are asking each client for a password. This is because we found a security flaw. That was like, let's say we start a server, and in our first implementation, we didn't ask for the password. Now we are asking for the password. See, to create a password. We are doing this because like we found out that when someone gets disconnected, and let's say an attacker comes in with the same username, then he can play the game. But now what we are doing is whenever one client joins, we are asking for their password, so that no other person is able to join as an attacker and play the game instead of the original person who was playing the game. Let's say A1 and then A2. And now let's say second player got disconnected. Now we are putting A4. The first player is getting the message which is opponent disconnected. But if we didn't ask for the password, then what would have happened is the attacker would have come with the same name. Let's say Nitin. But now we are asking him for the login and registration or login. Now if he tries to log in with some random password, we say authentication failed. This is how we are ensuring that the person who were actually playing the game are are actually the one who were in the game and not an attacker. Thank you.